So let me introduce myself. My name is Christian Glatschke from Splunk. Who's German here in the room? So I'm from Bavaria, so it's better to speak English because my German is really lousy. First, who knows Splunk? Who's heard about Splunk before? So, the rest, Splunk versions? It's always easier to impress the virgin. Okay, so Splunk, what is it? So what I'm going to do is to give you a short overview about what is Splunk, so what's the company, who's behind Splunk, what's the product, what's the aim of the product, what are we doing, and what's the big thing behind Splunk, the secret sauce. Wrong direction. So who's Splunk? We are a small software company, we are 650 employees, so compared to Apple, Microsoft, IBM, we're really small. But based on our own thoughts about Splunk, we're big. So we are the headquarters in San Francisco, founded in 2004. And the first idea behind Splunk, the initial thoughts were Robert Dess and Eric Swan, our two technical co-founders, they were sitting together and thinking about what if you could do inside the IT the same that you're doing inside the web. Having a search engine, looking for anything you're interested in. So in Google, you type something, for example, Italian restaurant, Hamburg, pizza, whatever, you get a list of Italian restaurants. And their idea was everything that runs inside an IT creates messages. Log files, events, system metrics, whatever. And what if we can collect all these pieces of information in one search engine and search very easily by a search bar for whatever you're interested in and correlate all the different pieces of information and data in one environment. So this is in a few simple words the idea behind Splunk. It's a search engine. It's an IT search engine, and we can ingest all different kinds of data you can imagine. So the minimum requirement is it must be readable. So binary input doesn't work. Like I mentioned, we're 650 employees right yet. We had our IPO April this year, so we're still an independent company. We have more than 4,800 customers worldwide, and about 100,000 users worldwide. What does that mean? If I divide 100,000 by 5,000, that would mean that I have, in an average, 200 users per company. No, that's not the fact. There's a free version on the market, and we also count the free users within this users count. There's, for example, one free user located in UK. He's the gardener of the British Queen. And he uses Splunk to monitor his greenhouses. Humidity, temperature, is the window open or closed, is the door open or closed, stuff like that. So he uses Splunk for that. There's another company in the US with this nice fruit symbol. They're using Splunk to monitor their cloud environment, and they're making, for example, 120 terabytes of data a day. Of course, they're not a free user. They're an enterprise user. So that's about Splunk. And Splunk is a product. What is it? So very simple, once again, it's just a small piece of software. It depends on the operating system you're going to download Splunk for. It's between 35 and 70 megs, something like that. And like I mentioned before, the same piece of software. So we are not in we do not ship hardware or an appliance. We just ship a piece of software. The customers install the software on their machines. And the English gardener and this US company are both using the same binaries. A few megs a day, 120 terabytes a day. It's always the same piece of software. Of course, then we have to scale out the installation on multiple servers, of course, for this amount of data. So, once again, it's just a piece of software. Everybody of you is able and free and allowed to download the software. For example, monitoring your private network at home, or do other stuff. So, basically, we're an indexing engine. Like I mentioned before, we take each possible piece of information into Splunk, index that information, and make it searchable. So, for example, on Windows environments, we can, for example, read out registry informations. We can handle Windows event logs, even while they are primarily in a binary format. We use a local event manager to translate or transform the data into a readable format. On Unix operating systems, we can handle and read out configuration files. We can use syslog on the servers to forward and transport data. We can monitor the local file system. For you more interesting in the virtualization world and virtualized environment, we have specific add-ons, we call them maps, for Citrix, for example, to monitor a complete environment from a Citrix desktop, Zen app, the Zen server, the networks in between, the backend, maybe a NetApp storage or a database, and correlate all these different pieces of information together and offer you end-to-end monitoring and analysis tool for Citrix. The same is available for VMware, and as far as I know, even for hypervisor, it's on the roadmap.
Hyper-V, Zen server, VMware, KVM, OVM.
Okay, so within applications, there's no big trick. All the log files are normally in a readable format, and it doesn't matter which interface you're using, like Log4j, JMX, JNS, it's all handleable. So even typical messaging queues. On databases, of course, even the configuration files, order and query logs. So for example, answer who has touched my database, who has run which search to extract a different kind of data. By the way, this is a feature very popular at the moment within Swiss banks. Who has touched my database and wrote the information to a CD. The Germans didn't know that feature. And even in networks. So for the other ones, by the way, there were some IT administrators selling this information to the German tax government, those CDs. On networks, we are, of course, able to digest configuration files, syslog input coming from different devices, and even NetFlow. And once again, even while NetFlow is primarily a binary format, we can even translate that using, for example, NFDump or other interfaces. One of the biggest benefits now with Splunk is the ability to really centralize all these different kinds of informations. One of the biggest challenges as of today is everybody knows if there is a problem or an issue, the information I need is there. I just do not know where and how to get this information. So for example, application logs, on which server are they written, or network informations. So everything we need is there, but it's hard to get to the information. So what we do with Splunk, we collect these thousands of different sources and centralized informations in this indexing engine, or in the layer of multiple indexing engines. And from the top, we have the search head, and whatever I try to find, like keyword searches, like give me all error messages, failure, mistakes, whatever. The search head looks into the connected indexes and gives me the information back. So what I want to say about that is there's no more need to think about where is this information. Just use Splunk, index all the data into one centralized indexer, and just look at that engine. When we talk about data, big data, big data in a manner of lots of volumes, lots of megabytes, gigabytes, terabytes, then you need the possibility to scale out the installations. And the Splunk architecture is built on this scalability, so you can, for example, use Splunk forwarders, kind of agents, to be installed on multiple client systems. They are forwarding the data into a layer of multiple indexes plus search heads. So each of these layers is fully scalable. Let me give an example. Credit Suisse, for example, they have about, in one Splunk installation, 3,800 clients installed all over Europe, and they're centralizing the data in Zurich in their data center on a layer of 4 different indexes. So let me talk a little bit about deployment and integration. So a bit more about the architecture behind. Like I told you before, there's just one package of binaries to be downloaded. We've learned there are different functionalities that Splunk can be used for. So it's still always the same package of binaries, but based on the configuration I put into the binaries, I can change the role or the tasks of the binaries. So for example, I can make it a forwarder. A forwarder is basically a kind of an agent installed in the client system, collecting informations from there and forward the informations to the indexer, or a range of indexes. So you can, for example, handle locally file systems by monitoring the file system via tail, for example. If something is going to be written newly into the directory or into a single file, it would catch up immediately the information and forward it to the indexer. We can even run from within the forwarder different scripts to monitor, for example, the underlying operating system. Scripts like perf or whatever. Another functionality is the so-called deployment server. Now, coming back to the example of Credit Suisse with 3,800 different agents, if you want to make now a strategic change in a configuration, then you can make the change on one configuration file and then copy-paste 3,800 times this configuration file. If you have a student working in your department, it's a nice job for you. If you don't have a student, use the deployment manager because he's doing that automatically. The main service, the core service, is the so-called indexer. So he's retrieving the data, indexing all the informations, and if I run a search on the indexer, he gives me back all the matches based on my search, which I can define in a separated search hat. And the search hat is basically nothing else than just a web engine. It's not a Java-based web engine, it's a Python-based. It's called CherryPy, it's even open source, and we use that. So that also means that we do not have, there's no standalone client to be installed on your systems. You can use each and every common browser to connect to the Splunk server to retrieve information. We support, by the way, all common browsers. Meanwhile, not all common browsers support modern web technologies. Not to talk about Internet Explorer 7, for example. So, JavaScript, there are some issues. By the way, have you tested the new Internet Explorer? Is it now supporting JavaScript?
Yeah, all my apps that I've tested, it works.
Okay. So, next question. How do we get all this information into Splunk? How can I collect the data? We've talked about this forwarder, but in some specific cases, it's not possible to use a forwarder. Just think about network devices, like Juniper, Cisco, whatever. Then you're normally not able to install a client directly on a network device. So then we're using, for example, syslog as a transporting layer to forward data from these devices to a file server or directly into the indexer. So the indexer can have a listener on a UDP port and ingest directly the UDP income. So we can use syslog. We can even connect a Splunk indexer via a shared directory or a mounted file system to remote directories, which is not really smart, but possible. If you install Splunk as an indexer, as a service on a Windows machine and making a member of the local domain controller group, then we can even remotely read out WMI information from remote Windows systems, or even connect to a remote Active Directory and read out Active Directory information. But if you use a Splunk forwarder, you have a lot of benefits compared to syslog, for example. Just think about syslog. What is syslog doing? they take the line of one event, so single line, forward this line via UDP port 514 to a file server, and that's it. If the information is really collected on the target system, if it's reaching the target system, Splunk doesn't care, it's file and forget. What the Splunk forwarder is able to do, we can run him in a data acknowledgement mode. So he sends a TCP package to the indexer, and just if the indexer acknowledges, I got the whole package, he deletes the package from the internal cache. So it's much more security in data transportation. So data acknowledgement. The next thing is I can create a secure connection via SSL between forwarder and indexer. We can compress the data before we send them via the net to decrease the network traffic. We can route and filter data via forwarders. The forwarder, like I mentioned before, can run local scripts. Doesn't matter if it's a shell, a Perl, or a Python script, or a batch file, just to, for example, collect local informations. Or we have, for example, customers who are using a local forwarder on their servers where the application servers are running. And if an application server is down, they use a local script to restart the application server. So even that one would be possible. So what they are doing is they are creating an alert in the indexer if the app server is down, and if the app server is down, the indexer gets an alert back and the local script starts the application server. And with a forward I can even do this local file monitoring that's of interest. If you want to, for example, monitor who is touching with which directory, which file, who is doing a change, for example. Imagine you have, you're responsible for databases or application servers, and you have this kind of property files, and somebody is changing a property value within the file, and you want to know who has touched the file, what was changed, at which time. Then you can use this fschange functionality within the forwarder to monitor these directories. And of course, Splunk is also able to communicate with external systems. We're not just an encapsulated world, so there are integrations into security event management tools like ArcSight or LogLogic. We have integrations into typical event consoles like Unicenter, Tivoli, or into service desk applications like a ticketing system of Remedy. So, and there are different technologies you can use, like SNMP traps, sending an email, sending an SMS, whatever. So there are different interfaces, and you can even connect the Splunk indexer via APIs or SDKs with other systems, for example, by using a Java web service. Even that one. And additionally, we can integrate external data and now correlate these informations with your log files. So an example here could be you have, for example, an account number, which is a cryptical number. And what you can do is you can now do a lookup and match this account number within my database or within my LDAP system to a specific user. So you can, instead of an account number, maybe you have a username, map this username with LDAP and get back the whole information about the real user behind. Or like here, where is it in my code? This activity code. It's not here, but maybe you have, for example, cryptical product numbers. And your manager gives you the task, create a dashboard that gives me in real time my top 10 products sold in my web shop. And then the manager is not interested in product numbers, he wants to have the product name. This information is not included in the log files. So what we're doing is, in real time, we are reading, parsing the log file information, parse the product number, make a lookup in a database or a CSV table, and display the product name instead of the product number. And of course, we have the ability to integrate Splunk into existing authentication systems like LDAP or Active Directory. So you can create within Splunk very specific roles with different capabilities, which means you can very fine granulated declare which user is allowed to use which dashboard, to run which search, to see what piece of information, down to a possibility maybe you have, for example, credit card numbers in your log files, clearly written. Not every employee should be allowed to read out a 16-digit credit card number. So what you can do is, based on his role that this user has, the credit card number gets to be masked. Is it right?
Mask.
Masked. Yeah.
Mask.
Masked.
Good.
English and US English. Okay, so what's the big trick behind? What's the secret sauce? I've talked now very often about this MapReduce, about indexing. So what is it? What are we really doing in the background? So at first, we take a piece of information. This could be a single line event, this could be a multi-line event. So single line events typically in network environments, multi-line events, for example, a Java, a log entry, class exception, 75 lines. Doesn't matter if it's 1 or 75 lines, we take this as one event, as one stream, and when this stream comes in, we parse this information and break it down in different pieces like IP numbers, timestamps, keywords, and even key value pairs. So key value pair is, for example, everything that's separated by a colon or an equal sign. So we read out this, we parse this information, and based on this parsing, we can later on use it. You see here, for example, this is a key value pair separated by a colon, which is shown automatically, sorry for the bad colors here, then as a field called IP length with a value of 20. And, for example, here we have an IP address. It's not shown here in the log file, in this information, which kind of IP address is it? Is it a destination IP? Is it a client IP? Is it a device IP? So, Splunk is, for example, pre-trained for web logs to read out this IP address and show it as a client IP. Once again, sorry that you can't see it here, but it's shown as the client IP. So when you now do the different searches on Splunk, you try to do analysis. And analysis by itself always expects structure. So if you think about the most common analysis tools, for example, for web intelligence, or more for business intelligence, they all expect structure. Even security and event information expects structure. So what they do is they use an early binding approach to get the structure into the data before they get stored. Why do they do that? Because they need to be stored in a database, for example. So I need to transform the data into my schema. If it's for security, I have to transform the information into a CEF format. If it's for business intelligence, I have to transform it in ETL format. So they all use this early binding approach. But the issue here is, if you do early binding, you have to know your question before you get the answer, or before you create a schema. So ad hoc queries are very complicated by that. What I mean is, if you have created a structure and you parse different pieces of information, you write it into a database schema, and now somebody comes and asks you, okay, but I want to get this piece of information over the last 30 days, then you have to say, oh, sorry, it's not in my schema, I didn't store that one. So what you have to do is recreate the schema, reload all the data, run your batch process again, and in 2 or 3 days you get the information. So that's a typical example for an early binding approach. I want to put this one into a database. So I've created a table inside my database, and I have now to transform like you said before, different pieces of information out of my log file to be stored in my database. That's a typical approach. And now, let me go back. Oh, the user agent information, for example, has not been stored. And now my manager comes back to me and asks me what was the most used mobile device during the last 30 days in my environment. If you do not have this user agent information, you're not able to answer that question. You have to reload all the data. So what we are doing is, within Splunk, we take this data, and it doesn't matter if it's structured or unstructured data. So this is very structured here. But now imagine you have a Twitter feed based on a JSON entry. A JSON file in itself is structured. All the tags are described, but the content of the tag text, so what the customer is really tweeting, is of course unstructured. So how do you want to get an upfront structure into this unstructured information? It's nearly impossible. Imagine Google would have had from the beginning on an early binding approach. Google wouldn't have worked. So what we're doing is we're taking this piece of information, even this unstructured information, what we make out of that is we make out of unstructured data, we make unstructured data. Wow, big trick. So we take the whole event, the whole piece of information, parse it down by MapReduce, and store the whole raw event data in our file system, plus the index informations. So when we do now a search, we do the search not on the raw data, we do it in the index files. It's MapReduce. It's the same technology that Google, Hadoop, Yahoo, others are also using. So we store them in the file system, and we use that for MapReduce. And the big thing is now we get the structure into the data right at the moment when we need the structure. So not upfront. We do a very late binding by dedicated searching. Really dedicated searching which piece of information I need. And therefore there's no real data science necessary. It's a very easy approach with a very easy, learnable and adoptable search language by approximately 70 different functions and commands. So what we do is we use, like Google, a very basic approach, a search bar, where you can type, for example, show me all events that include this specific IP address. So we send the search into the indexer. The indexer looks internally in the index file if there is an entry for this IP address. And if yes, he gives me back all the informations in the file systems, in the raw data, all the different events that include this specific IP address. That's very easy just by keyword search. But now getting more structure, I want to run this search. So once again, give me all events back that have this IP address, that have a field called status, and give me all values by this asterisk, give me all values back for the field status. So I'm looking for the HTTP status informations related to this IP address. So the list of events is then forwarded via this pipe to a very simple command. So take all this information and chart it down, count it by client IP and status. So tell me how many different status informations did I get for this IP address. So once again, running the search. And now instead of a list of events, I get, for example, a table back. This is the IP address. This is the HTTP status 200, so okay. And see, for example, there were 2 events during my search time, 503, so it was unavailable. So this customer wouldn't have been happy. And instead of using a table, I can even visualize in different graphs like column chart, bar chart, pie chart, whatever. Gorgeous. There are different kind of visualizations available in Splunk. And this is all very easily to be set up via drag and drop. So you can create these searches on your own, save the search, and reuse it, for example, in a dashboard. So, in summary, it's a flexible deployment model. Searches, indexes, forwarders, just scale them out. It's an open architecture. Like I said before, we have different SDKs to extend, for example, functionality of Splunk. So if you're a real good developer, you can create your own functionality on top of Splunk. Very easy example, it's also available now on the web, is, for example, the Google Maps integration. You're seeing an example in a couple of minutes. That was created by a partner in Austria, Siegfried. Then another example might be, we have this pie charts, yeah? But somebody wants to see a donut chart instead of a pie chart. A donut chart is not part of the basic distribution. But as we're using an open source library pie chart for this charting, you're able to create your own kind of visualizations. So, for example, a donut chart. Very easily done. Okay, that's so far about theory. So let's jump a little bit into a live demo. So let me explain you a little bit the live demo, what's running in the background. So we are monitoring here a typical telco environment. On the bottom right, we have sales clerks and different offices around a specific area. They are selling contracts for my telco company. Prepaid contracts, postpaid contracts with different plans. And all these informations are stored inside my BPM system, Business Process Management. And on the other hand, I have mobile customers, and I enable my mobile customers to download mobile content, like MP3 files, for example. And of course, these customers at first have to authenticate via a radio server, then they can download from my content server. And I want to get an idea, for example, how's the download working? And if there's something going wrong, what's happening in the system, or vice versa, I want to get some marketing information about the business processes running in the background. So at first, giving you an idea about this different kind of data that's coming in. And you see this is in real time, so the events are changing all couple of seconds. There are different pieces of information coming in. It's my radio system, it's my content server, and it's my BPM server in this case. So 3 different sources. If I stop that for a moment, you can pause the search. And you see there are different kind of entries, like this is a BPM entry. And this is a real good example of a log file handled by Splunk. I told you about this key value pairs. Yeah? For example, you have here an event equals update billing, timestamp equals properties equals, and so forth. So what Splunk is doing is it's extracting automatically for all these key value pairs in the background fields. And these fields we can use for analysis. So let's concentrate on this business event log entries. Just changing it to a different view. And as he's extracting only for this specific source, the log entries, I see now on the left-hand side, different fields. A field, for example, phone name. What Splunk has done is, in this case, we have hundreds of thousands of entries of this specific log format. And Splunk extracts on the fly for this specific period of time that I've chosen before, for example, the top 10 of the devices that are going to be sold within my environment. You can change very easily into a graphical representation of that. Just make a pie chart of it. So, suppose just a couple of mouse clicks. But once again, going back, These were the entries about the last 60 minutes. I can even, so there are different time ranges predefined. You can define your own time range. In this case, it's 5,000 events within 4 hours. And once again, it's all done automatically by this key value pairs. I can use, for example, now this piece of information. Let me go back to the phone name and just filter now all events that include this value for this key. And break it down into all informations just for this iPhone 4S 16 gig. And then get an idea which plan types have been sold for this, which was the most popular one, the unlimited prepaid contract, followed by 700 minute. So this is a little bit more marketing focused in this case. What you also can do is now correlate these informations. All these entries have either an IP address included, or a zip code included, or other coordination information is included. I can now parse this information out, in this case by zip code, create my longitude and latitude for that one, and display it as information on a Google chart. Back to, let me say, network examples, you can now visualize from where all over the world my clients are coming in, by which IP address, or maybe you have different data centers running. You can visualize them on a map and show, just then click, for example, on a location called Hamburg and get all the information of the data center in Hamburg. And this one is now, once again, over a period of the last 60 minutes, and you can do that even in real time. So really, as the informations are coming in, we are parsing them and displaying them in real time. That's not just for this kind of marketing information, so you can do that for each and every piece within your IT. This could be information about the server load of my Zen service. Could be about the physical usage, about CPU. Could be about specific issues in a Zen desktop, whatever. And all in real time. Let me give you another example. This is a very easy workflow created for first level support, for example. So imagine you're in the first level support and a customer calls you and he's complaining, he's trying to download content, he's going to be charged for the content, but when he hits the download button, he gets an error message. He's done it once, twice, 3 times, 4 times, and he gets pissed. He calls you. That means he's a real calm customer. He's quiet, talking very nice to you, and asking you to resolve the issue. In the first level of support, the only piece of information you get out of this customer is his mobile number. Not a contract number, not a name, his telephone number. And you can use that information now, put it here on top in a search bar. Sorry, it's really hard to see. Like 55, for example, it starts with a 55. And now specify a time range period and get all information for all telephone numbers starting with a 55. And then you see, okay, exactly, this is the MDM number, this customer has got a 503, service unavailable. What did he do? He tried to download something. In this case, artist and track name is not written, but here, for example, another customer, he tried to download Bruno Mars. He was not able because he got a 503. And what's the real issue here? If you have a look at this piece of information, they are all running iPhones on an OS 501. And this is, in this, to be honest, very simple example, that's the root cause. My download server doesn't support this operating system on the Apple device because it's a new one, they have a new integration, new functionality, it's not supported by my download server. I now know about this issue, so what I can do right now from the first level support on is creating a ticket for the developers to work on this issue. And I can tell the customer, okay, that's the problem. Be calm for about 24, 48 hours. You will get an reactivation for this download link plus 3 free downloads, for example. On a more technical basis, it could look like that. So this is the traffic by different hosts. And these are the failed downloads by host in a stacked mode. And I can see here in a more technical view, yes, the customer is right. There are a couple of downloads not working at the moment. So what I want to say about that is, you can use Splunk now for different roles, for different tasks. From a CEO, you just want to see numbers, like a dashboard like that. A real-time dashboard about the sales. So what's the revenue at the moment? Or you create a dashboard like we've seen before for more technical people, and all these different visualizations, all these different dashboards are all based on the same piece of information, just rearranged for different people. Okay, it's a bit earlier, but mostly I'm done. Do you have any questions so far? Yeah.
The log file parsing, is that done real time or is there an interval?
It's in real time now.
Real time.
So the log file comes in as a stream. We are parsing the stream, break it down into different values, like a key value pair, like an IP address, like a keyword. And this information are then going to be indexed. So the first there's a parsing queue, then the indexing queue, and then we are storing the information on a file system. So there's no database in the background, it's all 100% file-based. So you can write it on your local storage, you can write it on a sound storage, whatever you want.
So if the software is writing to the log file, you detect that and you start indexing right away.
Exactly.
But you write this in plain text file, or you do some kind of NoSQL databases?
It's no SQL, it's plain text, so the raw events are plain text files. We take the event, so let me say it like this, you have a log file on your client system. We read out the log file, line by line, put it into multi-line events if necessary, transport this information into the indexer, and only this piece of information out of this log file is stored in my raw data. Plus, on top of it, we have the index files, which are hash tables models.
Okay, but the question was, the raw data are really plain text files?
Really plain text files.
Even no node that SQL. That
No.
Yeah.
Plain text files. Yeah. So it's even like a no SQL language or technology in the background. It's plain text file. Yeah.
Communication to external sites, is that possible as well to read some information?
You can integrate, for example, via command line integration, or more smarter via web services, or create your own connector via our SDK. For example, creating a Java class which connects, for example, Splunk directly with a remedy system. It's nothing that we ship out of the box, but we have the ability, we are open by SDKs to create this kind of integrations. Yeah?
The data forwarding, is it the pushing or is it the pulling?
It's pushing.
It's pushing, and is it queuing? Is it real time?
It's in real time, and like I told you before, the forward is able to run in the state acknowledgement mode. So he pushes the data and waits for the acknowledgement that the package fully was written or received by the indexer. If we do not get back this acknowledgement information, we cache this package on the forwarder side and resend it a couple of seconds later.
And a couple of hours later, perhaps?
Even that.
I think of a scenario, say,
Yeah.
there's a very complicated change. Yes?
So,
everything is down or...
Absolutely. So what we do is...
And this is the most interesting
with a
stuff
maximum,
coming up again.
Yeah. We have a maximum amount of internal cache in the forwarder. If the cache is completely full, the forwarder stops to retrieve information, to read out information, but he sets a marker into the line, into the file. So if the connection comes back after an hour or 2 hours, he starts immediately to resend the first package in the queue, and the second and the third, and as soon as he is able to free the first packages of his cache, he starts to read once again from the log file.
And this is over TCP?
It's over TCP. Yeah.
One port, or is it
not-
dynamic port?
No, it's one static port.
It's one static fixed port. And
It's configurable, but it's
configurable.
yeah.
Yes, and do you have some staging? Say you have some DMZ. Is there perhaps a collector where you can put everything?
You can even interfere and collector in between,
Yes.
and then forward.
So you
from
have
there.
control.
Yeah.
So you have a controlled one
Yeah.
path.
Absolutely,
forwarding.
and you can even route different pieces of information out of the forwarder. So you have a forwarder that monitors at the same time a Java log file and syslog coming from a network device. So, and you have two separated indexes, one for the Java informations, one for the network informations. So the forwarder can even route the pieces of informations to dedicated indexes. And in another case, you can run in auto load balancing mode.
Thank you.
Yep, we're done. So, thanks for your time and have a great day in Hamburg. This is just in time. Out of battery.